Saturn's rings are among the most breathtaking structures in our solar system. Vast, luminous bands that seem almost unreal, suspended in space like a cosmic sculpture. From a distance, they appear smooth and solid, but in reality, they are a dynamic, ever-changing system made of countless individual particles, each obeying the laws of gravity. Understanding where these rings came from, how old they are, and what their future may be reveals a story that is both beautiful and surprisingly fragile.
The spectral data suggests this ring is made of ancient water ice.
That aligns with the hypothesis that it formed from a shattered moon.
The origin of Saturn's rings has fascinated scientists for centuries, and even today the full answer is still being refined. The leading idea is that the rings were born from destruction. Long ago, a moon or large comet may have wandered too close to Saturn and crossed a boundary known as the Roche limit, the distance at which tidal forces from the planet become stronger than the object's own gravity. Instead of remaining intact, the object was torn apart, its fragments spreading into orbit around Saturn. Another possibility is that early moons formed alongside Saturn, but later collided or were shattered, leaving behind debris that eventually flattened into rings. Either way, the rings are likely the remnants of something that once existed as a solid world. What makes this even more fascinating is that the rings may be surprisingly young compared to Saturn itself. Saturn formed more than 4 billion years ago, early in the history of the solar system. Yet evidence gathered from the Cassini spacecraft suggests the rings could be only about 100 to 400 million years old, younger than many dinosaurs that once roamed Earth. Their bright, icy appearance supports this idea. If the rings were as old as Saturn, they would likely appear darker after billions of years of dust accumulation from meteoroids and space debris. Instead, they shine with remarkable brightness, suggesting a relatively recent origin on cosmic timescales. Though they look like a single structure, Saturn's rings are divided into several major sections: the D, C, B, A, F, G, and E rings, each with its own personality. The main rings stretch astonishing distances. From the innermost edge to the outer reaches, the ring system spans roughly 280,000 kilometers, wide enough to fit nearly the distance from Earth to the Moon inside it. Yet this immense width hides a stunning contradiction. The rings are incredibly thin. In many places, they are only about 10 to 100 meters thick, making them proportionally thinner than a sheet of paper compared to their width. If you could shrink Saturn so the rings were the size of a vinyl record, they would be thinner than a human hair. The rings begin surprisingly close to the planet. The inner edge lies only about 7,000 kilometers above Saturn's cloud tops, while the outermost faint rings extend hundreds of thousands of kilometers farther into space. The immense scale raises an intriguing question. How long would it take to travel from the inner ring to the outermost ring using our fastest spacecraft? If a spacecraft moved at about 160,000 miles per hour, roughly the speed achieved by missions like Parker Solar Probe relative to the Sun, crossing the full width of the main ring system could take only a few hours. However, navigating safely through the dense particle fields would be far more complex than a straight-line sprint, since the rings are filled with countless orbiting fragments moving at different speeds. Those fragments are primarily made of water ice, mixed with smaller amounts of rock and dust. Some pieces are as tiny as grains of sand, while others are as large as houses or even small mountains. The ice reflects sunlight efficiently, which is why the rings appear so brilliant through telescopes. Despite their delicate appearance, collisions constantly occur among the particles. These impacts are generally gentle, helping maintain the ring's flat, disc-like shape by dissipating vertical motion and keeping everything aligned in Saturn's equatorial plane. A natural question arises: why don't the rings simply drift away into space? The answer lies in gravity and orbital mechanics. Every particle in the rings is traveling sideways at exactly the speed needed to remain in orbit around Saturn. They are not falling into the planet because their forward motion balances Saturn's gravitational pull, the same principle that keeps the Moon orbiting Earth. Instead of escaping, they endlessly circle Saturn, each particle following its own path like cars on a massive cosmic racetrack. Could they ever leave Saturn's orbit? Under normal conditions, the answer is no. The particles lack the extra energy needed to escape Saturn's gravitational grip. However, the rings are not permanent. Over time, subtle forces slowly change them. Micrometeoroid impacts darken the ice and erode particles. Electromagnetic interactions and Saturn's magnetic field cause some material to spiral inward, a process scientists call ring rain, where icy particles fall into the planet's atmosphere. Gravitational nudges from nearby moons can also reshape the rings, creating gaps, waves, and spirals. Eventually, perhaps in another 100 million years or so, much of the ring material may either fall into Saturn or spread outward and dissipate, leaving the planet far less dramatic than it appears today. Certain events could accelerate this dispersal. A large collision with a passing comet or asteroid could inject energy into the system, scattering material or altering orbital paths. Gradual gravitational interactions with moons might slowly shepherd particles away from stable regions. Even sunlight and charged particles from the solar wind can influence tiny dust grains over long periods. The rings are therefore not static monuments, but evolving structures, constantly being shaped by both gentle and violent forces. Beyond their physical characteristics, Saturn's rings hold many surprises. They contain mysterious propeller features created by hidden moonlets disturbing nearby particles. Some rings are braided or twisted, held together by the gravitational pull of small shepherd moons that act like cosmic guardians. The rings also produce subtle radio emissions and even influence Saturn's atmosphere. Viewed from above, they resemble grooves on a giant record, silently recording the gravitational history of the Saturnian system. Perhaps the most astonishing fact is how temporary this spectacle may be. Humanity exists at a rare moment in cosmic time when Saturn wears its rings in full brilliance. If intelligent observers had looked at Saturn hundreds of millions of years earlier, or will look millions of years in the future, they might see a very different planet. The rings remind us that even the most iconic features in the solar system are not eternal. They are snapshots in a long unfolding story of creation, destruction, and change. In the end, Saturn's rings are more than just an astronomical wonder. They are a living laboratory for understanding how gravity sculpts matter, how celestial systems evolve, and how beauty can emerge from catastrophe. Every icy particle circling Saturn tells a piece of that story, a story written not in words, but in motion, light, and time itself. If you found this video useful, please subscribe to help keep the channel up for more deep dive explanations like this. Like this video to help it reach others, and comment to help shape what we explore next. Thank you.